Alright, so today we're going to be doing 4-7, which is going to be imaginary numbers. So, equations such as x squared plus 1 have no real number solution, so mathematicians define imaginary numbers to represent those solutions. The imaginary unit, known as I, is defined as the square root of -1 is equal to I. This is useful when working with square root numbers and negative numbers. A pure imaginary number is written in the form bi, where b is the real number part and I is the imaginary number part. So we're going to be talking a lot about imaginary numbers today. I just want to mention imaginary numbers, the word imaginary as you know in English, is not the same way that we utilize it in math. These numbers don't exist in the same kind of dimension or understanding that we use regular numbers in. But as we go through this lesson and lessons coming forward, they are going to, you're going to see the applications and how they're used. So they do have real world applications. So let's get started. So this allows us to simplify negative square roots, which we normally couldn't do before. So if you were to type this into your calculator, it would give you an error. So there's actually a way to alternate way to do it. So what you actually do is you are going to write the square root of 32 times the square root of -1. Now once you have that, you are going to simplify this square root. So every number is the product of x amount of numbers, so in this case we can write it as the product of two numbers. Now we want to think of the largest number that's a perfect square that will divide into 32. So I wrote the perfect square numbers on the side of the board, at least the first few of them, like 1, 4, 9, 16, 36. What number do you think is the largest one that's going to go into 32? 16. So we can write 32 as the product of radical 16 times radical 2. So does everyone understand why we're able to do that? So now part of this will be able to be simplified. So what is the square root of 16?
4.
And we learned earlier on the previous slide, what is the square root of -1? It's I. And then the square root of 2 cannot be simplified, so we just leave it as 4I radical 2. Okay? Alright, so moving on, we're going to do the square root of 16, -16. So we're going to rewrite this as the product of square root of 16 times square root of -1, which is going to be square root of 16 times square root of -1. What is the square root of 16?
4.
What is the square root of -1?
I.
So the answer is 4I. Alright. So we're going to rewrite this as the product of square root of -1 and any ideas of what the largest perfect square number that goes into 80 is? So 49 doesn't go into 80, 36 doesn't go into 80, 25 doesn't, does 16? Does 16 go into 80?
Yes, by 5.
Yes, it does. So we can do 16. We want to pick the largest one. So that comes out to be 4I radical 5.
Where did? Oh, never mind. Sorry.
You see it?
Wait, where did it come from?
The
Square root of
16.
16.
That's what I was going to say.
Yeah.
So this one I'm going to rewrite as the square root of -1 times the square root of 5. Is there any perfect square number other than 1 that will go into 5? No. So we're just going to leave it as I radical 5. because there's nothing else we can do with that one. Make sense? All right, are we good to move on to the next slide? All right. So note that we're going to be solving these quadratics, and oftentimes we're going to end up having to do a negative square root. So this is why we haven't done problems like this until we had learned about I. So to get x by itself, what am I going to do here?
Subtract it.
Good. We're going to subtract 81 on both sides. That's going to give me x squared is equal to negative 81. And then what can I do to both sides to get rid of the second power?
Square root.
Square root. That gives me x equals. Now whenever you do a square root solution, you always have to do plus or minus, because when you square a negative number, it's still positive, so that's why there's the negative version. And what is the square root of negative 81? 9 I. Remember, we have that negative 1 that comes.
Okay, I was kind of confused why we could do negatives just because you put an I, because it's not an actual
Exactly.
square root of 9, it's an imaginary 9.
Exactly. So, yes, so I'm not going to write it out as negative 1 every time anymore now that we got the general idea. I'll just write, if it's a negative square root, I'll just write the I there. So, just keep that in mind. Alright, so here we're going to get x squared by itself. Subtract 9 on both sides. I get 2x squared is equal to negative 8. Divide by 2. I've got x squared is equal to negative 4. I'm going to square root both sides. X equals plus or minus 2i. So what the plus or minus means, so if you were on a quiz and I said select all the possible solutions, you would give me these two solutions, x equals 2i and x equals negative 2i. So keep in mind that I'll accept that I'm fine with you writing this on the homework as your answer, but on a quiz or test, it may have it written as two separate parts. All right, so just make sure you recognize both. Does everyone understand what I'm saying? Okay. So number 7, I'm going to subtract 15 on both sides. That's going to give me 4x squared is equal to negative 24. I'm going to divide both sides by 4. I've got x squared is equal to negative 6. I square root both sides. That gives me x equals plus or minus I radical 6. Make sense? Okay. Now moving on, we're going to do number 8. I subtract 13 on both sides. That gives me x squared is equal to negative 12. I square root both sides. That gives me x equals. Now this I can break down into, I know it's going to be plus or minus, and I know it's going to have an I in it somewhere, right? But what can I break down negative 12 into? But I'm trying to find a perfect square number that goes in.
4 and 3.
Good. So I got 4, 3, and negative 1. So what is the square root of 4? Square root of negative 1?
I.
And square root of 3 cannot be simplified. Make sense? All right. So number 9, I'm going to add 5 to both sides. I've got 3x squared is equal to negative 441. Divide both sides by 3. I get x squared is equal to negative 147. I square root both sides. So I know that it's going to break down and give me a plus or minus. So it's going to break down into negative 1. And then any ideas of the biggest perfect square number that goes into 147?
144.
No, it has to go in like evenly divide. No decimal. So 64 doesn't work. 81 doesn't work.
41.
40 what?
21.
21's not a perfect square. One of those numbers on the board. 49 goes into it, doesn't it? So 49 times 3. So what is the square root of 49?
7. So these x
7i.
equals plus or minus 7i.
Mm-hmm.
Radical 3.
Good. Perfect. Good job. Alright, I'm glad you're on board with it so far.
3 radicals.
Uh-huh.
Like where it says like 147.
The
Does it
order.
matter the order it goes in?
It doesn't matter the order it goes in at the radical stage because multiplication is commutative.
What about I like x?
Good question. Yes, it does kind of matter because your radical should always be the last thing you write, and your number should always go before I. So for that reason, that's why I goes in the middle. The reason we put radicals at the end is because it's easy if I put an I here to look like it was under the radical. So that's why radicals always go at the end, so there's no misinterpretation. You're welcome. All right, next question we're going to do. So when I see a negative fraction, I always bring the negative up to the numerator. It's just easier to work with that way. What can I do with that negative 1?
Add it.
Mm-hmm. How can I get rid of division in math?
You would have to times the 18 by 3.
Good. You multiply by the denominator, which gives me negative 2x squared equals.
54.
Good. Then I divide both sides by negative 2. That gives me x squared is equal to negative 27. And then what do?
Square root it.
That comes out to be x equals plus or minus. Now, this breaks down into radical negative 1, radical,
9,
Uh-huh.
and radical 3.
good. So what's my final answer going to be?
3, okay. 3i
Mm-hmm.
radical
3i
3.
radical 3.
Good. So those are our two answers. Everybody good with that? Alright, so now we're going to talk about patterns of I. So the thing is, when you get into harder problems, you're going to end up with situations where I becomes squared and becomes to the third power. So we're going to learn about how we deal with that today. So the thing about I is that the pattern of I repeats itself in basically a pattern of 4. So we're going to talk about that now. So I to the 0 power is 1, because anything to the 0 power is 1. I to the first power is I, because anything to the first power is itself. I to the second power is negative 1. And that's because if we think about how radicals work, we know that I is equal to square root of 1, or negative 1. So the square root of negative 1 times the square root of negative 1. When you multiply a square root by itself, it just becomes whatever's inside of that square root, which is negative 1. So that's the reason that I squared is negative 1. Now from there, we can then use that information to get I to the third and I to the fourth. So I to the third is the product of I times I squared, which would be I times negative 1, which is negative I. And then I to the fourth is I squared times I squared, which is negative 1 times negative 1, which is 1. In that pattern, I, negative 1, negative I, and 1 repeats itself basically every multiple of those numbers. So those are the only answers, 4 answers you will ever get for an exponent of I to some power. Alright? Well, I'm going to explain it now, so I don't expect you to get it right off of that. Alright. So I to the first power is just I, which is just I. I to the second power is I times I, which we can also write as the square root of 1 times the square root of 1. Square root of negative 1, which is negative 1. I to the third power is the same thing as I times I squared, right? That's the exponent rule. I times I squared is I to the third, which means that it is I times negative 1. Anything times negative 1 is just the opposite sign of whatever that was, negative I. And then I to the fourth is I squared times I squared, which is negative 1 times negative 1, which is 1. Okay? So now you're going to notice how the pattern repeats itself. We're going to do I to the fifth through I to the eighth. So how can I rewrite I to the fifth? What times what?
I squared.
Uh-huh.
And times I to the third.
Good, that's one way to write it. And you could also write it as I times I to the fourth. Either one would be acceptable. So from here, we're going to solve each of those. So what is I squared again? Negative 1. What is I to the third? Negative I. So what's negative 1 times negative I?
1.
It's just I, right?
Oh.
So you see how it comes out to repeat the same pattern? How could we, sorry, what? How could we rewrite I to the sixth? 3 and 3, that works. We can either do I to the third times I to the third or I to the fourth times I to the second, and you get the same answer either way. So this is negative I times negative I, right? What is negative I times negative I?
I.
Positive I to the
Second power.
Second power. What is I to the second power, according to the chart on the left there?
Negative 1.
Look, the pattern's repeating itself. How could we rewrite I to the seventh? I to the fourth times I to the
3.
third. Good. What is I to the fourth according to the chart?
Maybe 5. Oh, wait, that's
1.
Yep. And then what is I to the third?
Negative I.
What's 1 times negative I?
Negative I.
Look, it repeats itself again. And then lastly, I to the eighth is I to the fourth times I to the fourth, right? I to the fourth is 1 times 1, which is 1. So you're starting to see how the pattern repeats? So the good news is you can figure out any I to any power based on these simple principles. But the problem is you don't want to do I to the 343 and write it out. You know what I mean? That's going to take you all day. So there is a trick, and I'm going to show you that trick. So because I repeats itself in a pattern of 4, we can figure out which one it's going to be based on dividing that exponent by 4. So if you take the exponent and you divide it by 4, and the decimal comes out to be 0.25, that means that your answer is just I. If you do the math and you divide your exponent by 4, like we said to do, and you get a decimal of 0.5, then that means yours is x squared, or I squared, which is also known as -1. So your answer is -1 if you get a decimal of 0.5. If you do the math, divide your exponent by 4, and you get 0.75, that means you have I to the 3rd power, which is also -I. And then if you do the math, and you get no remainder at all when you divide by 4, that means you have I to the 4th, which is also what? 1. So those are the 4 options you have to any of those problems. Those are the only 4 answers you're going to get when you have I to a power. Alright? Those 4 answers. 1, -1, -I, or 1. So we're going to use this information to help us on the next slide. So I'm going to do the first problem the original way, just to show you what I mean by this. So I can rewrite 21, I to the 21 as I to the 4th times 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 I to the 4th 5 times, and then it would just have one more I, right? That would cover 21 in the exponents. 4 to the 4th power 5 times, and then an extra I would give me 21. Does everybody understand the reasoning behind that? So what is I to the 4th?
1.
So this would be 1 times 1 times 1 times 1 times 1 times I, right? What does that all come out to be? I. 1 times I is just I. Because of the I at the end, 1 times I. Yeah.
So if we have an I like anywhere in there, the answer is going to be I.
No, because if you had 2 I's, then it's I squared.
Okay. But like the I usually goes over the 1.
Yeah, because
1 times 1 times 1, that's like 1.
exactly. Yeah.
Then I, just I, so then we
Correct.
instead of saying 1, we say I.
Yeah. Yeah, because there's no, you don't have to say 1 I. Yeah, it's just like a bunch of, these are all pretty much useless, right? So you can do it that way, or here's the trick. Instead, you take your exponent and divide it by 4, okay? And you're going to see what you get when you do that math. You get 5.25. What does the chart say when you get a decimal of 25? It says the answer is I. So that's a faster way to do it, instead of doing it all out. So I just wanted to show you why it works at the top, but you don't have to do that every time. Okay, you can just do the quick way. Okay, so do you want to write it out 50 to 50, or do you want to just do the simple way?
Simple way.
50 divided by 4 gives me what? 12.5. 12.5, and the rule says if it's 0.5, what's my answer? -1. It's I squared. $147 divided by 4, that comes out to be
36.75.
36.75. So what's the answer here?
-5.
And then the last one, this one you can probably do in your head. This just comes out to be 4. So if we have no remainder, just 1. Which makes sense because I to the 16th is I to the 4th times I to the 4th times I to the 4th times I to the 4th, which is 1 times 1 times 1 times 1. Okay. So before we move into the simplifying radicals again, with more steps, Know that you can never multiply negative radical 1 times negative radical 1. You have to simplify it to I before you multiply, okay? So when working with imaginary numbers, treat I like a variable and simplify using algebraic properties. Once simplified, convert any I term according to the pattern of I. Okay. So I'm going to zoom in here so we can go ahead and solve. So what is 3 times 4?
12.
And what is I times I?
I squared.
What did we learn that I squared actually is?
-1.
-1.
So what's 12 times -1?
-12.
Not so bad, right? Alright, moving on. What is 2 to the 3rd power?
8.
8. That's going to be I cubed, right? Because we got to cube the I as well. Times 5I. What is 5 times 8?
40.
And then it's going to be I to the
4.
4th. What is I to the 4th again?
1.
So the final answer is what?
40.
40. So there's 2 ways to do this one. I prefer the way on the left, and then I will show you how you would go about doing it the other way. So we're basically going to do it like we did on the last slide, or the last few slides ago. We're going to do each one individually, okay? So radical 20 breaks down into -1 times, what can I break down 20 into? 4 and 5, right? So what is the square root of 4?
2.
What's the square root of -1?
5.
Square root of 5 stays as is. Now we're going to do this side over here. So that's going to be the square root of 1 times, what's 12 break down into?
3 and 4.
Good. What's the square root of 4?
2.
What's the square root of -1?
I.
And the square root of 3 just stays as is. Now we're going to multiply these together, okay? What's 2i times 2i?
4I squared.
Good. What's 5 times 3? 15. And what is I squared?
-1.
What's 4 times -1?
-4.
-4.
Now radical 15 doesn't break down because there are no perfect square numbers other than 1 that go into 15. So that's as simplified as it gets. Does that process make sense to everyone? Alright. Now here's the other way you can go about doing it. So I can rewrite this as the square root of 20 times I, right? Times I radical 12. So does everybody see how I got to that point with the problem? I just took out the negative and made it an I. Now what you can do instead is multiply the outsides and the insides. So what is I times I?
I squared.
Good. And what is 20 times 12? What's 2 times 12?
240.
240. Now what you can do instead is break down the 240. So 240, we know that I squared becomes -1. 240 breaks down into 16 and 15. What is the square root of 16?
4.
What's 4 times -1?
-4.
So see how we got the same answer doing it 2 different ways? Does everyone understand that? Yeah, I'm gonna leave it up. I just zoomed out because I was too zoomed in. Which one do you prefer?
That one.
Left or right? Really?
Yeah. Because there's nothing useless stuff.
Yeah, but would you have known that 16 and 15 are factors of 240 if I didn't tell you?
No.
Right off.
Absolutely not.
I mean, if I'm here, you know, it's easy, but. Alright, anyways. So let's go ahead and try 18. So, what is negative 6 squared?
36.
What's I squared? Negative.
Negative.
Final answer?
Negative 36.
Does everybody understand the part where you square the I and it becomes negative 1? Okay. So over here we have I squared.
Ms. Ross, when I squared negative 6, I got negative 36.
It's because you didn't put parentheses around it. So this becomes I squared radical 3 times 64 I squared. So does everybody see where I broke it down there? How I got that? So when you square a square root, does anyone know what happens?
Becomes cube.
No, that's
It becomes big itself.
good. Yeah, it becomes whatever's inside the root. Exactly. Because square root and square cancels each other out. So this just becomes a 3 right here. Okay? And then if it's a 3 times a negative, or times I squared, it's actually 3 times negative 3 times the 16. Good, but the 16 is actually what?
64.
Yeah, I'm sorry, I don't know why I say 16. Times another negative 1, right, from this I squared, okay?
Would be a negative 64.
It would be negative 64, so it would be 3 times negative 64, which would give me a positive answer, right, of 3 times 64. I don't know why I want to keep saying 16.
192.
192. Yeah. Any questions on that? Alright. So this one is a bit of a procedure, so just follow all the steps here. So I'm going to rewrite this. So this is 3, the number on the outside, times, it's just going to become I, right, when I take out that negative, times the square root of 4 times the square root of 6. So does everybody see how this became this? Do you have any questions about that part? Alright, so now I'm going to do the other part. So that's going to be 2 times I times radical 9 times radical 2. So this became this. Does everyone see how that happened? What is the square root of 4?
2.
2.
What's 2 times 3?
6.
So it'd be in 6,
Radical 6. Now over here, what's the square root of 9?
3.
3 times 2 is?
6.
I radical 2, right? Now we can multiply these together. What's 6 times 6?
36.
36. And then I times I?
Negative 1.
That would be squared, so it'd be negative 36.
It would make it negative. And then radical
6.
6 times 2?
Oh, no, 12.
Now here's the problem. Is that the final answer?
No, because you could go further. It'd be 4 and 3.
Good. And then what is the square root of 4? 1. No.
2.
Yeah, 2.
Okay.
No, you're good. I don't know why I said yeah.